Diode are also known as rectifier. Okay, it's also called a rectifier. But what is a rectifier? A rectifier is the components, electronic components that used to change alternating currents to direct currents. Okay, and this process is called rectifications. So a diode can change alternating currents to direct currents. So therefore, a diode is called a rectifier, and the process, the process to change alternating currents to direct current is called rectifications. It's called rectifications. So, and for rectification, we are two types of there is two types of rectification: a half wave rectification and full wave rectification. I will show you the half wave rectification first. Half wave rectification. Let's say initially we have an alternating current. This is the displays of the scatter ray oscilloscope. Okay, and for alternating currents, the displays is something like this, right? Okay, so we have discussed this a few weeks ago, right? For I think 2 weeks ago. Okay, the displays of alternating currents in is a scatter ray oscilloscope. Okay, so now this is the okay, this center lines shows the dividers of the directions of the currents. Okay, so above this line, the current move forwards. Let's say the current move clockwise. Okay, the current move clockwise. So here the current move clockwise, and here the current move counterclockwise. Okay, counterclockwise. So the current it moves like this, clockwise, counterclockwise, clockwise, counterclockwise. So that's alternating currents. Alternating currents, it keep on changing the directions of the flows of the current. So the current flow clockwise, anti-clockwise, clockwise, anti-clockwise. So the displays of the scatter ray oscilloscope is like this: clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise. Okay, and the current actually increase, decrease, becomes zero, increase again, decrease to zero, increase again, decrease to zero, increase again, decrease to zero. Okay, so this is alternating currents. Okay, now this alternating currents occurs if there is no diode. If there is no diode, there's no diode here, then it occurs. Okay, if there is diode, then there's another story. Okay, if there is no diode, then okay, clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise. So clockwise, anti-clockwise. But if we connect a diode here, what will happen? Okay, so if there's a diode here, now if there's a diode here, it moves clockwise. So if it's clockwise, is forward bias or reverse bias? Clockwise, forward bias. How do we know? Okay, you check the flows of the current. Okay, you see the directions of the current is the same as the directions of the arrow inside the diode, right? Okay, so if the directions of the current same as the directions of the arrow, this is forward bias or reverse bias? Directions of the current same as the directions of the arrow inside this diode. So this is forward bias. Okay, so when the current moves clockwise, then it's forward bias. Forward bias. Forward bias, the current can flow. Current can flow. So forward bias or clockwise, the current can flow. Then how about reverse bias? How about if flow counterclockwise? Okay, you see when it flow counterclockwise, this is the directions of the current, right? But the directions of the arrow in the diode is in the opposite directions of the current, and this is reverse bias. Okay, reverse bias. Reverse bias means no current flow. No current flow. Okay, so if we move clockwise, fine, forward bias. But it try to move backward, reverse bias occurs. Okay, and no current flow. No current flow means that this current, there's no current flow here. Okay, so this one we don't have this. Okay, so no current flow backwards. Okay, so current can only flow clockwise. No currents can flow counterclockwise. Then means that the current can only flow in one direction only. Clockwise, clockwise, clockwise. Okay, the anti-clockwise cannot. Okay, reverse bias. So no current flow anti-clockwise. So clockwise, clockwise, clockwise. Okay, so then you have clockwise, nothing here. Clockwise, nothing here. Clockwise, nothing here. Okay, So this diode successfully convert an alternating current to direct current, right? It changed alternating currents to direct current because the current can only flow in one direction only. No current flow backwards. So the current only flow in one direction, okay? And initially, okay, it's like a wave, right? It's like a waveform, okay? But now we cut off the currents that flow backwards. So these types of rectification is called half wave rectification. Because why? Because just half of the wave remain. The other half is cut off already. So the final waveform on the screen is the positive half only of the original AC waveform. Just the positive only. The negative cut off already. So this is called the half wave rectifications. Okay, and in this half wave rectification, the negative part of the current is prevented from passing. The negative part cannot pass through because it's reverse bias. Okay, smoothing. So for half wave rectifications, the waveform is like this. Okay, so increase, decrease, no current, increase, decrease, no current, increase, decrease, no current. So it means that the supply of the current is not steady. Currents, no current, current, no current, current, no current, and the current increase, decrease, increase, decrease. So this is a non-steady current, and we don't like this. We don't want this. We want to have a continuous, steady currents. Okay, and how to do that? We connect a capacitor to this resistor here. What the function of a capacitor? What's the function of a capacitor? Is to keep charge or to store charge, right? Yes, to store charge. That's correct. Okay, let's see what happens if you have a capacitor connected parallel to this resistor. Okay, first, if it move forward bias, right? So forward bias, the current move, go up, come to this point. Okay, okay, it complete the circuit. Okay, and at the same time, it will go to the capacitor. And when it go to the capacitor, it will store the charge here. It will store the charge here. So you see, during forward bias, the current can flow, and at the same time, it will charge the capacitor and store some of the charge inside the capacitor. This is during forward bias. Okay, so it charges the capacitor. Then how about reverse bias? Okay, now let's see what's happens during reverse bias. Now during reverse bias, the charge is still inside the capacitor. Okay, initially at the very beginning. Okay, initially the charge is still inside the capacitor, and the currents tend to flow backwards, anti-clockwise. But we know that this can't happen. This won't happen. Why? Because reverse bias, current cannot flow. So current cannot flow during reverse bias, but just now we already store some charge in the capacitor, right? Now, this capacitor, it will release the charge. Okay? It will release the charge. So, if you connect this to the CRO, to the cathode ray oscilloscope, then you will see something like this. So, forward bias, the current increase, okay? Increase, okay? But when the current tries to start to drop, when the current start to drop, okay, then the capacitor start to play a role here. It will give current to the resistor here. So then the current does not drop to the zero, okay, but because it get the current from the capacitor, okay. So this is the current from the capacitor. This is from the capacitor. Is the current from capacitor. Okay, so you see, forward bias, we keep some charge in the capacitor. Reverse bias, the capacitor will give the charge to the circuit. So the currents that we get is something like this. Okay, we charge the capacitor, then the capacitor release the charge. Charge the capacitor, capacitor release the charge. Charge capacitor, capacitor release the charge. Okay, so then we successfully convert this one, non-steady direct currents, increase, decrease, no current, increase, decrease, no currents, non-steady direct currents to a steady direct currents. So this process is called smoothing. Okay, smoothing. So we connect a capacitor parallel to the resistor here. Okay, then we can smooth the current. So this is smoothing. Okay, so the capacitor charge up when current flows from the diode, then discharge through the load when the current from the diode is 0, and smoothed in this way, the current through the load is similar to the steady direct current which would flow from a battery. Okay, it's like a battery. Okay, it's a straight line. You can see it almost straight line. Okay, almost straight line.